let us analyze sheet metal bending process. For that, we are going to use static structural analysis. Let me double click our static structural. Here, I am going to give the sheet metal as a non-linear material. So let us double click our engineering data. In engineering data, let us click engineering data source. From there, we will select general nonlinear material. Under nonlinear material, we use aluminum alloy nonlinear. Let me click this plus symbol to include that for our analysis. Now let us close this engineering data. So let us import our model. So let me right click this. We select import. We select the model. So the model is imported. Let us go for meshing the model. Let me double click this. Now you can able to see there are three geometries here. The first one is a die. At the top of that is upper die and lower die, and then the center you have the sheet metal which has to be bended. So for our analysis, we are concentrating only on the sheet metal. So in geometry, let us select the base of that, and we will make this as a rigid body. Similarly, let us go for the top base and bottom base, change this to rigid. Only the sheet metal which you are going to consider has to be analyzed, so that has to be flexible. Below that you have material assignment. Change our material assignment to aluminum alloy nonlinear. So you can able to see the nonlinear effect is yes. So once it is selected, so if it is no, you change this to yes. Now you can able to see there is a question mark in the connection. Let us go to the question. Let us go to the connection. Under that you have a contact here. So this contact is considered as a bonded contact. So only process here is the contact, what it is considered, the contact and target is not matching properly. To match this, let us right click this. Let me change the flip contact target. Once it is done, you can able to see that. So you don't have that question mark symbol. It has become a tick symbol. Similarly, I have to include one more contact, which is the contact between the surface of this and with respect to the die. To create that, let us right click, insert manual contact region, select the top of this, we click apply, then select these areas by pressing Ctrl. So the area of the die which has to be going to be contacted. So let me click this also, apply. So this should be a rough surface because it is going to act as a rough. Let me select rough. So I can able to see that that is also been included. If it is not included, we have to right click and we have to flip our contact and target. The next step is we have to include two more joints. First, let me right click and create insert joint. The first joint is your body ground joint and it's a fixed joint. The fixed joint is your die. Select the die and then click OK. So this joint is fixed. Next, you have to create one more joint. Let me create, right click and create joint. So this is also from body to ground, and this is a translational joint. Select translational joint and then select the top region of it. We select the top region of this and then click apply. Look at the direction. So the direction is towards upward direction, but we need the die to come towards downward direction. So go to coordinate system, change the direction from upward to downward. So now you have a correct downward direction. Now let us identify what happens if it is hitting this particular piece, sheet metal. So to do what you have to do, let me right click this. Let me go for disable transparency so that you can able to view your entire model. Now select the particular translational joint, click configure. Now let us move and see how much direction it has to move. So I can able to see that I can move this die up to 33 millimeter. So this is very important to give the analysis setting according to that. So I am going to move this up to 25, 20, 30. Let us consider I am going to move this up to 30 millimeter of projection so that you can use that for analysis purpose. We click revert. Now let us go for meshing. Click mesh, right click, click generate mesh. So the mesh has been created on the surfaces. Now let us go to right click. We go to settings, select joint load. In the joint load, we have to select this translational motion. In translation, we are going to have a displacement. The value of the displacement is 30. So as we discussed, so the value has to be mentioned based on how much it can penetrate. So specify as 30 mm ramp. Now right click the solution, go for deformation plot and also the stress plot. So once this is done, let us solve the problem. Click solve. The problem will take some time to solve it. Once it is solved, we can look after this. One thing I forgot, you have to go to analysis setting. Make sure the Raj deflection is on. Let us analyze it again. I got an error, so I am analyzing this again. Once it is done, you can able to see the deformation which is produced on our model. So this is our total deformation and this is the stress which is developed on it. So by animation, you can able to see how the stress is developed when you bend a sheet metal. So this is one of the additional exercises which you can understand and you can try it out accordingly. And make sure that this analysis will run only in version greater than ANSYS 14. So the lower version is not working on this particular multi-body analysis. Thank you.